Hey everybody, day 2 of Box and Whisker plots, and we are working on the analyzing. So we did this one yesterday, we created them, so now we're going to compare two sets, and we're going to recognize outliers. We're going to compare and analyze our Box and Whisker plots. We're still working on Standard 9411. So, to interpret the Box and Whisker plot, separate group, we have 4 separate groups. We have quarter 1, quarter 2, quarter 3, quarter 4. Each separation represents 25% of the data. So 25% is in here, 25 in here, 25 in here, and 25 in here. So if that's 25% of the data, we got to look at, is that data scrunched or spread out? So we can say that from quarter 1 to quarter 2 is very tight set of data. All of those data points are within a small area. We can say that quarter 2 to 3 is very spread out in comparison. We have the same amount of data points, but they cover a much larger set on the number line. So we can say that quarter 1 and 2 is very compact, and quarter 2 to 3 is very spread out. So we can talk about how spread out the data is or how clustered the data is. The other piece that we want to talk about is the range and interquartile range. The range is the highest minus the lowest. So in this case, it was 56 minus 0. The range would be 56. The quarter 3 minus quarter 1, the interquartile range, is the length of just the box. So what happened between the first and third quarter? In this case, we would do 41 minus 9. And 41 minus 9, just make sure I do it right, is going to be an IQR, interquartile range, of 32 points with that subtraction. So, looking at a data set, here we have minimum, Q1, median, Q3, max. What percent of the data lies between 33 to 63? Well, that's one piece of our graph, which is going to tell us that that is 25% of the data. Same graph here. What percent of the data is less than 88? So if we look now from 88 and less than, well, how many sections is that? This is 25%, this is 25%, this is 25%. So if we want to talk about less than 88, we're going to say 75% of the data. And another follow-up question is, what is the range of this data? For the range, we take our highest minus our lowest, 95 minus 33, giving us 62 as the range. And for the IQR, we're going to take Q3 minus Q1. 88 minus 63 is an interquartile range of 25. All right, here's a new data set. Price of watches at a store. If all the watches are under $45 on clearance, what fraction are the watches on clearance? Well, that's 25%, 25%, so that'd be 50%. 50% is 0.5. We would call that 1/2 of the data is on, or the watches are on clearance. The range, we have biggest minus smallest. 120 minus 16 is 104. And the IQR, 50% of our data is in between 71 and 31, and that would be 40. So it's minimum, the middle 50% is between $31 and $71. All right, not too bad. This is pretty decent stuff. This is a great time for you to hit pause and complete monitoring progress 2 and 3. It is very doable with where we're at. But if you want to just wait, we can do 2, 3, and 4 at the end here. So here, what happens when we put 2 Box and Whiskers on one set of number line? All right. So comparing the jellyfish in A to B. Well, what kind of jellyfish were these? The smallest was a 1/2 inch, and the largest was 5 inches. Well, in sample B, the smallest was 6 inches, and the largest was 19 inches. So we can tell that every jellyfish in sample A was smaller than the smallest jellyfish in sample B. And it says, what percent of the jellyfish are greater than 10 inches in sample B? Well, half of them are greater than 10 inches. Okay, one thing that you can't see from a box and whisker plot, you have no idea how many data points are represented. You only know that 25% from sample A, 25%, 25%. So that could be 25, 25, 25. That could be 100 jellyfish, or it could be 2, 2, 2, 2, and we could have 8 jellyfish. We don't know how many were counted. We just know that it is a percentage of those values. Okay. Again, 2 box and whisker plots. We have city A and city B. It says true or false, city A and B have nearly identical median temperatures. Well, the median for city A is 55 and the median for city B is 39.5. So I wouldn't say that the medians were the same. I would say that they're about the same spread out. If I look at the city A's range, 72 minus 39, we get 33. 60 minus 19 for city B is 41. So we can say that city B has a bigger range of data temperatures. City A is a little warmer data temperatures, but is spread out less. City B's goes colder, but is spread out more. So those are a couple of ways that we can compare our data sets. All right, we have Dallas and Houston for normal precipitation. How many months was the precipitation in Dallas more than 2.7 inches? Well, here's 2.7, that's the median, so we'd say 50%, which is about 6 months. All right, to compare these two data sets, we go from 1.5 to 5.4 inches of rain in Dallas. That gives us a range of 3.9 inches. Well, in Houston, we have 5.7 to 2.9. Quick math, we get a 2.8 range. So we can say that Houston has a they're very similar rainy months, very close here, but Dallas has a much drier set of months. A quarter, actually about half of their months are a lot drier than in Houston. You can see that Dallas has a much bigger spread. Their first quarter in both are pretty compact, but we can say that their minimum to Q1 in both are spread out, and our Q3 to max is pretty spread out in both. But about half of our months in Dallas are a lot less rainy. All right, so we're going to talk about calculators in our next session, but go ahead, complete the second 11.2 assignment on big ideas and get those monitoring progress done so we can kind of check in with how you're doing. Email me with questions that you have and make sure you're checking Google Classroom for any more videos. Good luck. Hope you guys are having fun and enjoying your time at home. See you soon.